there is a projectile motion given with an initial launch velocity, an angle. The initial velocity is 34 feet per second, and the launch angle with the horizontal plane is 60 degrees. The horizontal velocity vector is the product of the launch speed and the cosine of the angle. Since it is 34 times cosine, 60 degrees, it equals 17. The vertical velocity vector is the product of the launch speed and the sine of the angle. Since it is 34 times sine, 60 degrees, it equals 17 square root of 3. For an object moving at a constant horizontal speed, the distance traveled after time t can be expressed as the product of speed and time. Therefore, x equals 17t. Here, we use the horizontal velocity component calculated earlier. For the height, we need to use the position function. This function is very familiar to students. It includes the acceleration due to gravity. Let g be 32, the initial position be 0, and use the previously calculated vertical velocity component. Summarizing, we have the following parametric equations. Let's graph the position of the projectile over time t. At any time t, if we denote the angle of ascent of the projectile as theta, it becomes the slope of the tangent at that point, if there is a smooth curve. With given parametric equations, the slope of the tangent at a point x and y is defined by the following formula. Both the numerator and denominator are the first derivatives with respect to the parameter t. Let's solve the given problem. To find the slope of the tangent, we first take the derivative. Differentiating with respect to the parameter theta, we obtain a somewhat complex relationship, but it simplifies to negative 2 sine cubed theta cosine theta. First, when x is negative 2 over square root of 3, we need to find the angle theta by substituting the given value and simplifying for the cotangent. We find that it is 120 degrees. The slope of the tangent is found by substituting the radian value of 120 degrees for theta. Simplifying, we get 3 square root of 3 over 8. The equation of the tangent is easiest to find using the point slope form. By substituting the given values of x and y and the slope we found earlier, we can simplify it. Second, when x is 0, we need to find the angle theta. By substituting the given value and simplifying for the cotangent, we find that it is 90 degrees. The slope of the tangent is found by substituting the radian value of 90 degrees for theta. Simplifying, we get 0. Using the point slope form, we substitute the given values and the slope we found earlier. To get a horizontal line, y equals 2. Third, when x is 2 square root of 3, we need to find the angle theta by substituting the given value and simplifying for the cotangent. We find that it is 30 degrees. The slope of the tangent is found by substituting the radian value of 30 degrees for theta. Simplifying, we get negative square root of 3 over 8. Using the point slope form, we substitute the given values and the slope we found earlier to simplify it. It's that easy! See you next time.